Hi there. We are today solving a linear system, or a linear quadratic system, and in this case, we're going to be using the substitution method. Now, if we had a linear system, we could use the elimination method, where we line them up and add them together. But in this case, whenever we have a squared term, we are kind of stuck with the substitution method, which really works well. So let's start the problem here. What I'm looking for is I have a circle and I have a line, right? So this equation here is the circle with two squared terms with coefficients that are equal. And in this case, we have no squared terms here, where this is a line. So these will intersect in either 0, 1, or 2 points. And our solution, what we're looking to get in the end, is again a point or two. In this case, there is going to be some solution. So what we might want to do at the start is just to write down sort of how we're going to end here. Our solution or solutions are going to be a point or possibly 2 points, but it's important to know where the end game is here. We're looking for a point. So if I find an x-coordinate, that is simply my x-coordinate of a point and not the entire point. So we're always coming back to this solution, or in the end getting a point. So with substitution, we're going to look at one of the equations and we're going to solve that equation for x or y. So when we look at this equation, this is difficult here to solve for x or y. We don't want to deal with that here. We're going to go over to this equation here, and you're going to think about which unknown is easiest to solve for, x or y. And it appears that if we just add the y to the right, we have then solved for x, and we're in pretty good shape. So that's what we're going to do here. So we're going to add this y to both sides, and we have x equals y plus 5, or 5 plus y, however we want to write that. And now what we have is we have solved for x. In this case, x equals 5 plus y. So whenever we see an x in the future, right over here, we can replace it with what x is equal to. We see that's equal to 5 plus y. So in this x, before it's squared, I'm going to sub in a 5 plus y. We're going to use parentheses here, which are very important, and we're going to square that, and then we have y squared equals 25. So right there is, that's my substitution here, where we just went ahead and we wrote down 5 plus y wherever we saw the x. See the x here, we write the 5 plus y. It doesn't look like a y there, but I'll change that there. There's a y. Okay. So what I have to do here is I have to take this 5 plus y and multiply it by itself. Now we can do that on the side here, and we'll take a little quick trip over here. And if you want, you can use your tabular method or another method that works. And we see we have 25. You have a 5y here. Y times 5 is 5y, and we get a y squared. So in the end, what we have here is we have y squared plus 10y plus 25, and that's kind of the work on the side, and that's going to lead back into what we have over on the left. So we're going to write this as a y squared plus 10y plus 25 plus this y squared that we had equals 25. And since we have a y squared, we have a quadratic equation, and we always set it equal to 0, right? Of course. So we have our y squareds here. I'm just going to combine the y squareds. I'm getting a little concerned about the space I have on the board here, but I think we'll be alright. So I have 2y squared plus 10y plus 25 equals 25. And I do want to set this equal to 0, so we will move this 25 over by subtracting it, and we will get 2y squared plus 10y equals 0. So I have a quadratic equation which may not look exactly like we think, I'm trying to use, there you go, look at that. Okay, so we're going to move that up to the top, and hopefully we're good here. Okay, so what we want to do here is we want to factor it. So we're going to take out a greatest common factor of 2y, which will leave a y plus 5, and set that equal to 0. Since we have two factors, I can do a t-chart and set each factor equal to 0. This y would equal 0 on the left-hand side. In this case, we'd get y plus 5 equals 0, and by subtracting the 5 on both sides there, we would get y equals negative 5. So what I found is the y coordinate of each of the 2 points. Now, going back to the top here, what we have, just going to make these a little bigger here, we have found the y coordinate of 0 and the y coordinate of negative 5 of my 2 points of intersection of the line and the circle, or what we call the solutions. So in order to find, and we're just going to write this in here, we have y equals 0 and we have y equals negative 5. I need to find the corresponding x values, and since that point is on both the line and the circle, I can go back to either one of the original equations, either this x minus y equals 5, or probably not this one, but it would work, x squared plus y squared equals 25. I'm going to stick with the linear equation, which seems much easier there to work with. So what I have is, I have my y equals 0, I have my x minus y equals 5, and I'm just simply plugging in. Wherever I see a y, I'm plugging in a 0, and I get, in this case, x would equal 5. And my point would be 5 comma 0, and I'm just going to put that up top there as my solution there. And I have the same thing for this y equals negative 5. I'm writing in my original equation, and I'm subbing in, I have to be careful here, I'm subbing in a negative 5. So I have x minus a negative 5, which is x plus 5 equals 0, equals 5. And hence x would equal 0, and this would give me 0, negative 5 as my other point. So put it up top, a quick box here. This is my solution. In fact, there's 2 points here, and these are the 2 points right here and right here that are the solutions to the system of the circle and the line. And I can check these points back into the original by subbing in the x and the y in both equations, and I will get a check that the left side equals the right side in each case. Alright, so this is a fun problem, and just kind of the normal method of going through a linear quadratic system. Have a great day and good luck on your test.